The CVM Indexer is a program that runs on a drive as a standalone program. It's programmed with a GUI. It runs in the background as a low priority. After the servo loops are closed, when there's time left over, it'll run. It's kind of slow, maybe 100 instructions per second, about 5 to 10 millisecond update rate. And before we write a CVM control program, we're going to take a look at where the guides are. So under Help, All Documents, we can see there's an Indexer guide, and we can see there's an ASCII Programmer's Guide. I'm going to use the ASCII Programmer's Guide to send the I command to change an indexer register, a program variable, and the Indexer User Guide to look up some instructions. So in the Indexer Guide, we can see there's a bunch of functions. These are Java beans which reside on the computer and add function to the CVM Indexer. And the one I'm most interested in is move. There's home. There's wait for time delay. And there's a conditional jump. There's other functions that are useful, like get or set any parameter in the drive, and other parameters that become useful. So have a look at the guide there. In the ASCII guide, we can see the I command. This is the syntax for reading and writing an indexer register. It's just I space R0 for register 0. There's 0 through 31 registers in the drive. So before we look at the CVM control program, we're going to take a look at the drive. I've just powered up. I have a CVM control program in the drive, so the indicator is green that the CVM control program is running. But it's not doing anything. I didn't give it a go command, so nothing's going to go. And the system has not been homed yet, so the motion in my program is without respect to home. What I like to do before I write a program is use the CME2 scope to test out my mechanical system and make sure I can do what I want to do. So in this case, I'm going to make a 10 rev rotation forward and a 10 rev rotation backwards. And we verified with the scope that the system can do that. And we can even see the typical current on the scope for that move. And it looks like the RMS current for this move is about 1.4 amps. So maybe a little bit more if I reduce the dwell. So right from the beginning to the end of the move. So there's a typical RMS current for a typical move. Also, I want to run my homing routine to make sure it works. I can home and then save, and then I become referenced. I'm going to use this homing method and this move in my CVM control program. So we open up the CVM control programming screen, and we can see the I/O, the inputs and outputs that could be used in the program. I'm going to stop my CVM program from running. I'm going to look at the Setup tab. So rather than use inputs as BCDs, for example, I could say use input 2 to select sequence 0 or sequence 1, or a BCD to select several sequences. I'm going to use the indexer register R0 to select a sequence, and the go command is going to come from input 6, rising edge. So let's take a look at the program, sequence 0, sequence 1, and sequence 2. Sequence 0 is my main program because R0 is going to be the value of 0 when I power up or reset or start running a CVM program, so we can monitor the register values. So this first step is going to make a trap relative move of a distance of 10 revs at a speed in Excel, and then it's going to wait for the move to be done before it goes to the next step. That's exactly the move we did in the scope. There's a time delay for 10, 100, 1,000 milliseconds. We can do the move in the opposite direction, and we can wait for 1,000 milliseconds here. Now I'm going to add a step in this sequence 0 from the functions, and I'm going to do a conditional jump. So my condition will be if R0 is equal to 0, in other words, I could set it to something other than 0, I'm going to jump to sequence 0, step number 1. And so sequence 0, step number 1 is the move again. So this is going to repeat over and over. I'm going to do a conditional jump to sequence 2 if I have some kind of error while I'm moving. And sequence 2, I just programmed it as a disable function. You could do other things like clear the fault and try to move again, or just make a counter of how many times it stopped, and then go back and repeat again. But it's reliable for testing a mechanism. You can let it run for months, and it just sits there and runs back and forth. And sequence 0, sequence 1, I've programmed as the homing routine that I've tested previously, and this could also jump to sequence 2 if there's a problem. So I'm going to save this down to the drive. So now this is in the drive's flash. I could save it to a disk. I can reset the drive or hit play to test it. I'm just going to hit play. So again, we can see that the CVM control program, we can stop it. We can hit play. If you disable the drive, it will also stop the CVM program. That's a software disable. So normally on power up or reset, you don't do a software disable. I like to connect a switch to input 1 as a disable line, but I'm going to go ahead and toggle in 6 with in 1 low. So let's go to the inputs. So this is going to run the program. So we're still not referenced to home, but I'm cycling through the sequence. I'm enabled. And I'd like to use the CME2 ASCII command line. Let's do the IR0 command. Returns the value of 0 for register 0. And if I give it a value afterwards, I can see that I've set the value of R1. And that caused the program to stop cycling back and forth. I could, now that R0 is equal to 1, I could toggle the input and run the homing routine that I've programmed in there. So let's take a look at that here again, see if we can home the system. There, now I'm referenced to home. So now if I clear my R0, I space R0, 0, and I can toggle input 6 and run sequence 0 now. So toggling input 6 somewhere, there it is. So I'm cycling back and forth, and we'll open up the CME2 scope again, and waiting for trigger, collecting data. So we can run this system for months and months, and then come back and take a look at the RMS current to see if anything's changed. And so far so good. The RMS current's the same. No problem with this system running for a length of time. Okay, I'm going to try to introduce a momentary fault by cutting the AC power and connecting the AC power back up. This CVM control program was able to, on the, whether it's homing or running the sequence 2, ran to the abort handler or the error handler and disabled the drive. Okay, just a few side notes. I can stop the program. I can clear all the flash. That clears out the program that's in the drive. So I try to load it. There is no control program in the drive. If I did have a program in the drive, I could view this assembly code. So this is what code is in the drive. that handles the main program, which looks for the go line. And so we just add to this assembly code as we enter beans and functions. We can print the program, so we can copy and paste this information and print it into a document if someone wants to just get the program text for a record. We can check the bean versions, so if you add new functions, you can see what's in there. This is the user guide. Stop the control program. And save and load new files. And just delete it from Flash again. This is the information about the Indexer 2, version 201, the main Indexer bean. And yeah, the CVM Indexer itself, it's just a function or a bean that runs to create the code to load to the drive. This is for maybe like a PLC program, toggling I/O. If you're a real software programmer, maybe we don't use a GUI. You know, we have the CPL, Copley programming language, which is like a Motion Basic or a C program. Essentially, it writes the code down to the drive, but in a higher level language. So you can do loops and whiles and waits and if-thens rather than, you know, a GUI. But the CPL requires a programming license and is designed for a real software engineer. I'm not a real software engineer, so I use the CVM Indexer to do my little programs. You can do a lot with the CVM Indexer. Still, it's a single axis of control. It's not designed for multiple axes. You can talk to multiple axes over the serial port, each one running its own CVM program. That's fine, but there's a lot of machine state control that you'll have to be careful of if you make your own machine that uses the CVM Indexer. If you're going to talk over the serial port or over a CAN port, you might as well use the serial ASCII protocol and do your own state machine and control upstairs. And definitely if you use CAN Open, there's programming software for CAN. CMO is the Windows version of CAN Open programming, and CML is the C++ library for, you know, like a Linux operating system programming language. But for our needs, single axes of just move it back and forth and let it run for a test. This is a great way to test out a mechanism. Okay, thanks for your time. Take care.